related to the machine learning algorithms. And we have seen certain aspects, like k nearest neighborhood. So that is probably the first algorithm where one can implement or specify the supervised learning kind of the let me move this guy. Okay. Now, just what we are observing here is this is one more important classifier where we can perform the activities like as per the requirement. So just we can make use of the classification. Okay. So let me introduce what exactly this Naïve is and where do we use these kind of the technique. Actually, some sort of things I have compiled for us so as to dig through the concept. The very first important thing is, friends, in the observation, maybe in terms of supervised or unsupervised or all these kind of things, the fundamental aspect is when do we use which kind of the algorithm. So that is the basic point we need to observe. Okay,
Based on the problem, right?
based on the problem. Okay. So
Mm.
similarly here, if you refer these naive Bayes, there are certain considerations, friends. Actually, if you observe this thing, so naive Bayes is a classification model, like where it is basically a classification model based on the Bayes theorem. I'll
Oh,
introduce you because the objective of the session is let us study about the Bayes theorem. This is
okay.
the first thing. And thereafter, we'll see in what way. Okay, so I will take some example problem also. Like in a email, okay, suppose I'm having some email and I want to find out whether that mail is a spam or not spam. Okay, so
Okay.
this case study involves all these mathematical aspects also. So, like the probability aspects related to the stat, all these things will be seen. So, let us see what is the basis for the Naive theorem. So, before going to define this, let me ask you this thing. Suppose I am having a scenario where this particular scenario specifies that I'm having some features like F1, F2, F3, F4, and F5.
Okay.
And never mind whether this is a strong contributor or weak contributor, assume that this F2 is the strong contributor. All
Okay.
these F1, F3, F4, F5, they're all weak contributors. Observe one
Oh,
point, friends, here. If I am adding all these weak contributors, tell me, friends, whether I am getting the impact or not, overall impact.
oral is negative only, Pawan.
Negative in the sense, not the
Like
negative
oh,
contributors actually,
okay, okay,
not the
okay.
negative
Weak
contributors.
entity. Okay. Weak.
Weakly contributing. Of course,
Yes,
maybe
yes,
I
yes.
can say strong means some 0.05 effect is
Mm.
there, and here I
Mm.
may get 0.001,
Okay.
0.002, like that. So if
Okay.
I'm adding all these things, friends, obviously I may get some kind of the impact.
Mm.
Okay,
Yes.
rather than dealing them individually, like week one feature and week two feature individually, maybe it is having some sort of less impact. Whereas if I can able to get all these things into a common platform, definitely we can expect some sort of the impact on our classification or whatever we are applying. Okay,
Yes.
that is the first point we need to observe. The second important point is generally, practically, friends, there is no possibility of independent features. Suppose if I'm talking about the employee data, okay, I cannot say that my employee number, designation, qualification, these things are never independent features. They are dependent
Yeah.
only because if I'm saying Purna or if I'm saying Dr. Pawan, definitely designation will be there and qualification. But the expectation here is, friends, in case of the nail base, okay, so very first point we have seen, the first point is we are giving preference to both strong and
Weak.
weak learners. This is the first point we have to observe. So
Okay.
whenever the naive Bayes comes to your mind, then definitely you observe that your naive Bayes give preference to all the learners, maybe
Oh,
strong or weak or whichever. Second
okay.
point is if the features are independent, okay, independent. So friends, practically if I'm saying taking the data set, maybe in your implementation also you have gone through the Titanic data set, diabetic data set, weather data set. They are having some sort of dependency of one feature with another. Yeah, generally as a row, if you consider starting from the
Mhm.
database perspective, they are having the dependency, but you may feel this particular definition may be a bit strange in terms of this naive Bayes. Just have a look on this, friends. So your naive Bayes is a classification model based on the Bayes theorem with an assumption of independence among predictors.
Questions.
Okay, na? Independent means F1 is there, F2 is there, F3, like that. I'm having certain kind of the features. And practically, okay, if these particular, my assumption is I'm not having any dependency among them. Okay, maybe I can treat them independently. Okay, and all these particular independent features, if I want to make use for the classification, then I can make use of the neighbor. Second thing is a naive classification or classifier assume that the presence of a particular feature in a class is not related to the presence of any other feature. Suppose I'm putting in this way. If I want to observe or the presence of the F1 is not depending on the F2
F2.
or any other kind of the feature. Okay. So with this, just we're having the enough background. Purna, can you mute? So heavy, many members are there in your home. Since-
Uh,
okay. Whenever you are having doubts, just you unmute. Okay.
sure,
So,
sure,
however,
sure.
we are recording this one now. We are sharing with all others. Okay.
Okay.
So these 2 points, hope clear. The very first point is, just we are giving the preference to both strong and weak learners, and features are independent in nature. Okay. Now the point is, so how do I make use of this particular naive Bayes in the understanding of? Because of course you can get many points related to this naive Bayes kind of thing, where if you are making use of the naive Bayes kind of thing, there are certain aspects where we are making use of the Bayes theorem and we are providing some sort of building a corresponding classifier example. All these things are pretty common. Now you observe here, just at the moment I am making use of the convention to classify, okay, a given text or some kind of the data, have a look on it. It is very simple and powerful algorithm for the classification based on the Bayes theorem with an assumption of independence among the predictors. Just now we have seen independence among the predictors, and it is easy to build and particularly useful for very large data sets. So this is preferably if I'm having a large data set, then I can make use of that convention. Next thing is it describes the probability of an event. Just as I said, if you are referencing the naive Bayes, it is based on the Bayes theorem. So just we'll talk about that particular thing also in a while. And based on the prior knowledge of the conditions that may be related to the event. Suppose if I'm making use of some probabilistic analysis, whereas probability of B given A, probability of A given B, like that we're having certain terminologies. I'll be introducing those kind of the terminologies in a while. So these kind of the things are very much helpful, and the probability based on the probabilistic analysis, one can implement the naive Bayes. Now observe here, friends. I'm talking about the probabilistic analysis, and I'm saying, okay, the entire thing is based on and revolving around the Bayes theorem. Let us try to observe what do you mean by probability and how we need to observe. Don't worry, friends. Just I'm giving you the working principle of the naive Bayes, but in the reality, just with the help of, however, in the coming sessions, I will be taking some case study and I will implement. I'm going to implement that, but what I'm trying to give is the what is the basis for the naive Bayes. So on what basis naive Bayes is working, and what is the stat or mathematical model behind the naive Bayes algorithm. At the moment, you see some kind of the data set, you should be able to observe whether I can apply naive Bayes or support vector machine so as to decide as a data scientist, that is also a very important point to decide which algorithm I need to elect. Now, in this case, observe here, guys. Finding probability of event B when event A is true. I know that A is happened, and now I want to find out what is the probability of B occurrence. Okay, so the probability of B given A, the formula is like this: probability of A by probability of A given B by into probability of B, where we are knowing some of the aspects. While making use of these kind of the conventions, our clear convention is there is no without any correspondence. That is what we said F1 and F2 without any dependency. Okay, they are making use of, we can make use of those kind of the features in the naive. And of course, guys, if you are referencing the probability of B given A, which is a posterior probability, that means probability of event B after A is true. Suppose after occurrence of the A, what could be the value of the B? Based on that particular convention, we are going to observe this implementation. And probability of A given B, the conditional probability that A occurs given that B has occurred. As I said, no, B already occurred, and I want to find out the occurrence of the A. So just to keep these points in mind, however, we are doing some kind of the case study related to substitution of these kind of things, and I am picking up some kind of the example, friends. So where this kind of the example is pretty helpful to observe the orientation of how we are going to apply. But before that, which are all the steps need to be considered so as to solve the given problem with the help of the naive Bayes. So simple steps, friends, just to have a look on this. We are going to recheck one by one step in the implementation. And first, we need to consider and analyze the given data set. Okay, maybe if want to find out whether a particular statement is spam or not spam, so that I should be very clear about what exactly my data set is. And next thing is classify the data set into different categories with the labels, because label is, as you know, guys, while talking about the supervised learning, okay, we clearly observed that there should be some sort of labels: label 1, label 2, label 3, label n, like that. So out of these particular labels, our interest is to find out the outcome. Now, after that, after classifying these data sets into different categories, we need to apply the naive-based classifier and the train the machine on the data set. So training in the sense model, friends, our model, whatever the model we are taking, and just we are giving the data set, and we are going to get the corresponding model implementation. And after training, generally, friends, we are going to test, okay, whether our model is performing well or not, all these kind of the things. And finally, the highest probability value will decide the category of the query. Okay, so you will be get the clarity once I implement some kind of the example related to these five steps. Okay, so don't worry about these five steps. After completion of the example, sure you will be getting the clarity about the appropriate concepts what I'm talking about. Now, let us understand this particular case study, friends. Okay, just I am yeah, giving you some sort of the table. So this particular table, what it is giving us is, so as you know, the data set consideration, here I am having the text along with the category. So share your OTP, definitely is a spam kind of thing, because this is known to us earlier data, all the existing data. Secure your OTP. Generally, the bank sends the message to us, friends: secure your OTP, and as well as don't give your card details to any other. Banks never call. Okay, just we have picked up those kind of the data items, and especially in the spam orientation, if you observe, share your OTP belongs to the spam based on the existing conditions, based on our experience, and give me the CVV. This is also the spam orientation, and share me PIN number. This is also belongs to the spam. Now, based on these kind of things, I need to find out, okay, whether the given query, okay, whatever the query I am working with, that particular query is spam or not spam. And what I'm trying this thing is based on the available data. My query is send me your OTP. Okay, so maybe may not be exactly the similar words, but in reality also we may not get the exact words. But I want to find out whether this particular phrase is also spam or not. Okay. Now observe the second point is here. Consider and analyze the data set. And what analysis we can do from here? Just to have a look on this. We can analyze in such a way that so whatever the words I'm having. So here share appeared one times, your OTP, secure is another, and this is OTP, and maybe 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. Now the total words print actually. Okay, the analysis in the sense, observe here, what I am trying to get the appropriate data set is just I am from the case, I am generating step 2. Okay, be cautious. It's very simple. I am generating these things friends from the given data. Total number of words in the data set. Total number of words in the data set. Just now we have seen the total 18 words we're having. Okay, so just we'll get this thing. And next thing is, be with me guys, total number of, okay, total number of words in the spam category. Have a look on this guys. So just I'm having the spam here, 3 times spam appeared, and share your OTP 3, and give me CVV 6, and share me PIN number. So 6 plus 4, 10. Okay, so out of these two categories, spam category votes are 10. So that means total number of votes in the spam category are 10. Now, another thing, similarly, total number of votes in the non-spam category. Here, friends, of course, total 18, 10 are spam. Obviously, 8 becomes the non-spam. It becomes the non-spam. Okay, now so likewise, just we are analyzing the data. How our algorithm is going to analyze just ourselves, we are analyzing the data. And what else we can do, friends? I can ask you this thing also. Maybe while performing the text-based kind of things, total number of distinct words. Okay. Now, if you observe this thing, friends, if you observe out of 18, share got repeated 2 times. Okay, -2, and your got repeated 1, 2, 3. So 5 words I have to remove, and OTP also got repeated. Okay, so around if you observe, so total we will be getting the 12 distinct words. Now you see, this is not a difficult task. No? Like for the just to simplify, I'm having some humanly possible counted words. So in that particular case, I was given some set of the statements. In that particular case, what I'm doing is I am working with number of words in the data set. Total number of words is 18, and total number of words in the spam category. Total number of words in the non-spam category, and total number of the distinct words. And next, what I want to do is next the step 3 is in this particular case, I want to consider the query. Okay, whatever the query I want to implement, what I want to do is related to that particular query, I want to evaluate. So the query evaluation. Okay, so evaluation in the sense here I can use a classification or classifier. Now you observe, guys. My query given by whatever the query we are considering is send me your OTP. This I want to find out whether this particular thing is a spam or not spam statement. Now you go back to the probability theory, friends. From the known things, whatever the things I am knowing, I want to find out the unknown thing. Okay, because something like probability of A given B, Already I know B, but I want to find out A. So in that particular case, let me substitute this thing, probability of send me your OTP. If I am substituting this thing. And now what should I do, friends? Here, just probability of sending into probability of me into probability of your into probability of OTP. Individual words. Okay, so what we are doing, just we are computing the probability of each and every word, and then we are going to verify whether that thing is available or not. Now, if I want to check out like this, friends, probability of send me your OTP, whether this is a spam or not. Because we know some of the statements are spam. Now I want to find out whether this is a spam or not. Yes, as I expected, a little change in the formula. How I can do probability of send. Okay, already I know the spam orientation into just a substitution. Probability of me, spam, again into probability of your spam, and then probability of OTP again in terms of the spam. Don't worry about these things, friend. Just at the substitution, definitely you can observe what exactly we are doing. So just we are mentioning that. And similarly, another statement to understand in a better way, just observe here, guys. Probability of send me your one-time password OTP, and I'm assuming this is a non-spam word. So for this particular thing, similar substitution, same word repetition, probability of send. Just I need to spend non-spam into probability of me, non-spam, okay, into probability of your non-spam and probability of OTP non-spam. So just if you observe this kind of the analogy, now let me give a try on the substitution because these formulas okay, and now I want to substitute the things. Now what I want to know whether this is spam or not. I am having this word actually. Send me your OTP. This I know. So what I'm doing here is guys, how many spam words we're having actually? What is the formula for this? If you go back, probability of A by B, if I'm talking, okay, something like this. Okay, just if you observe the similar kind of thing, just if you are making use of the convention, just you go back, this formula, actually I have mentioned, probability of B by A, probability of A by, okay, whatever the thing I am having, so in the denominator, and probability of A by B, A given B into B. Okay, so this A given B again, you can mention probability of A and probability of B, all these kind of the conventions. So just if you are making use of this convention, whatever I am talking about, okay, probability of B by A, okay, equal to probability of A by probability of A by B into probability of B. Now what we are calculating is guys, just there is some sort of okay spam word and appearing on that particular statement. Now total spams, if I am talking, just we have made some kind of equation here. So spam three times occurred, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if I'm talking about the spam, there are 10 words are there in the spam. So obviously, whenever spam is occurred, obviously I can substitute that particular thing. Let me take this particular diagram, friends, because we need to depend on these kind of the thing. Okay, just I am making use of this thing. Okay, right. So this is probability B given here. Okay, so and now what I'm observing is how many spams are there? Three times spam occurred. How many words are there, friends? One, two, three. Just I'm having one, two, three, and as well as 4, 5, 6, 7, 8, 9, 10. So spam equal to 10. Now my statement is, if you go back just these things. Send me your OTP. This is my statement actually. Okay, so send me your OTP. Now observe here, friends. Total, I'm having the spam or 10 words. Out of these particular three statements, do I have any send word? No, no, I don't have any send word.
Then
So
no.
0 by 10 into me, how many times appeared, friends? Only one time appeared. Me. How many times? One, two,
Two.
two times actually. In the first statement, we don't have me. Of course, non-spam we are not considering. Only we are considering the spam. So because our intention is just I want to observe spam by send your OTP. So in that particular case, first however I don't have any send kind of thing. So zero I have put. Next me appeared two times in the spam category. So what I am doing here is guys 2 by 10 into next thing is your. Your how many times occurs? Just to observe here one time, only one time. 1 by 10. Now I need to observe OTP. OTP how many times observed? One. This is also one time. But there is a danger, friends. In the multiplication, if you are observing zero into anything, it becomes zero. But our goal is not satisfied actually. If in these kind of the considerations, we need to observe one more property called because in naive base, SPM, decision tree, definitely we have to remember these things, friends. Those things are nothing but Laplace estimation. Okay, Laplace estimation. Okay, what we mean by the Laplace estimation is if any value is zero in the computing, then it is becoming as zero probability. Okay, so it is zero frequency leads to final value as zero. But how do I solve this particular thing? Excellent equation, friends. We need not bother about zeros or whatever the things. Just a simple thing is what they have mentioned is suppose if I want to find out the probability of a word, what should I do is just to count the word. As of now, what we have done, count the word plus add one more thing. Though it is zero, no problem. Zero plus one we are adding, it becomes one by something. And next thing is total number of words in that category because category however what I'm talking about is related to the classification we're having yes or no kind of thing. Okay na? So that means whatever the category, yes category, no category, or here if I'm talking about spam category, non-spam category, as we are talking about the spam, only the words in that particular category plus. Okay, so word count plus 1 by whole by friend, this is total number of words in that category plus total number of distinct words. Okay, so where if you are referencing this particular alpha, sometimes this alpha word count plus alpha, however, this is one. So what we are doing here is, though I am getting the zero value, but I can easily handle that particular situation in such a way that I can make use of that convention. Let us put this way: send me your OTP. That is the thing. P of send by spam. Now observe here, friends. I need to find out the number of sends in the spam. So just I'm again going back to this diagram because this is the data set actually I'm having. So again, I'm placing this particular data set here, handy. Now we observe here, friends. Send spam category I'm seeing, send is not there. So what I need to do is our word count. Just I'm substituting in the equation. Our word count is 0 plus alpha value 1. By what should I do is total number of words in that category. If you observe, friends, as a first statement of the analysis, we picked up four things actually. total number of words, total number of words in the spam category, total number of words in the non-spam category, total number of the distinct words. Now our requirement is total number of words in the spam category. How many are there? 10. So what I'm doing here, just you can substitute here. Okay, now friends, just you substitute here total number of words 10 plus what is the distinct number of words? Okay, how many distinct number of words are there? In our data set, we are having the 12 distinct number of words. So just you can substitute that 12 here. Okay, now whatever the value, 1 by some 22. I'll give you the value. So maybe I computed for us, maybe this is 0.045. Yeah, I calculated as a part of this demonstration. And coming to the second one, probability of me by spam. Denominator remains same now guys. Total number of words in that category plus distinct words. Now me we need to calculate. How many me's are there? Just to observe here friends. One, we got two me's plus we need to do the one. So which is nothing but 3 by 22, 0.136. Now what should I calculate? Send me your am. This remains same, 10 words, 12 distinct words. Your how many times repeated? So one time, uh, only one time, friends. Okay, this is also one time plus alpha here because to avoid the zero probability. 2 by 22. Again, that is 0.090. Next thing is, friends, your OTP. OTP of spam. Just this denominator remains same, 10 plus 12. And I need to check OTP how many times occurred. Only one time, guys. This is also. So 1 plus 1, which is 2 by 22, which is same as 0.090. Now, we could able to compute each word probability. Now, what should we do? We need to compute the probability of send me your OTP. Okay, now what should we do? All these things we should multiply. What is the value? First value is 0.045, 0.045 into second value is guys 0.136, 0.136 into 0.090 into fourth value also 0.090. The final value we are getting as a result of probability of send me your OTP is equivalent to I multiply after multiplication we'll be getting this value guys. Okay, so 49572. So that means probability of send me your OTP in terms of the spam, we got this thing. Okay. Now what is the next step, friends? Next step is we need to find out. Okay. So probability of finding the query in the non-spam category. So what we need to do as a next step, P of send me your OTP and I want to calculate the probability of this non-spam. Okay. So now the equation remains same. Each and every word. Okay. So the probability of the word I should compute and then given by total number of the non-spam words plus distinct words. Distinct words we know no? 12. Distinct word maybe in the spam or non-spam remains same. Now I should find out how many non-spam words are there. Just to go to up, already we have computed that. Okay, how many non-spam are there, friends? 8. This remains same for all the computings. So now what we are doing, 8 plus 12. Now I should find out in the non-spam category, how many send, how many me, how many your, how many OTP are occurred. Okay, for to keep handy, just I am copying this thing and again I am making use of this thing here. Now observe here guys. First I need to find out in the non-spam category, how many send are there. Okay, is there any send friends here? Secure your OTP is there. Don't give your card details. Only those things are there. So obviously, don't worry. We are having Laplace 0 plus 1 by 8 plus 12, 1 by 20. 1 by 20, I computed 0.050. What is it? P of send of non-spam. Similarly, P of send me your OTP. That thing, na? P of me non-spam. Now I need to find out. This remains same, guys. 8 plus 12. Now how many me's are there? Okay, in non-spam. Nothing is there. No? This is also becomes 0 plus 1. Okay, so 0 plus 1, which is nothing but 1 by 20. Again, this is also 0.050. Next, what should I see? Your. Okay, so for that, P of your by non-span. However, this denominator remains same. Our distinct values and number of non-span rows. Your I have to verify. In the non-span category, your occurred one time, two times friends if you observe. So 2 plus 1 by 12. So 3 by 20, which I computed for us, 3 by 20 is something 0.150. This is the value. And finally, OTP, no, the last word, OTP out of non-spam, which is nothing but uh, OTP how many times occurred? One time. Non-spam category only one time. So just I'm having 1 plus 1 by denominator remains same. There is no change. 8 plus 12, 2 by 20, which is 0.100. Now the final equation is what should we do? Friends? All these four probabilities we have to multiply. So P of send me your OTP in the non-spam category. In the non-spam category, what it gives? All these values. All my values 0.050, 0.050 into second value is that is also 0.050 into my third value is friends 0.150 into what is the other value 0.100. Now if I am multiplying all these particular probabilities, we'll be getting this equation 0.000040 and 375. So probability of send me your OTP in non-spam category. Now we need to compare as a step 3. Okay, actually we are having this particular other step after completion of this particular thing. Now we need to observe the consideration of the probabilities. So which are all the final probabilities, friends? The final probabilities are just now we got for the non-spam category, we got the probability as 0.40375. Now I should get the possibility of spam category where the spam we have computed now for the spam 49572. Okay, so four zeros remain same 495. Okay, up to 3 digits if you take. Now you observe friends. Actually, spam probability is greater than the non-spam category. Non-spam probability. Obviously, I can say now whatever the word we are talking, whatever the statement, send me your OTP having high probability value. So with naive Bayes, you can conclude the given statement is spam. Okay. See friends, how simple. Initially, maybe if you are making use of the convention, because the human tendency is like if I'm saying some probability or some kind of thing, you may be you may get some aversion. Oh, this probability, this case talking about the probability, all these things. But at the moment you are applying these things as a kind of the equation, and if you are making use of this convention, then it becomes very easy for us to see. But if you are observing these process friends, whenever you see the naive Bayes kind of the algorithm, then immediately these points should come into your mind. Okay, how do I'm picking up all the independent things? Because see, every word we are giving preference, friends. If you observe, we are not we are not discriminating any word, and we are not giving any priority to any word. But ultimately, so we can able to categorize the spam and as well as the non-spam kind of the things. Okay. So finally, from the above observation, okay, we can conclude that the appropriate thing is becoming is definitely the spam statement. Now, if we go back to our original algorithm, now if you read through, definitely you will get the consideration. Consider and analyze the data set. Yes. Classify the data set into different categories, spam and non-spam. Apply the naive-based classifier and test the machine. Just we are giving them words. Highest probability value will decide that category of the query. See, friends, how simple and straightforward. Okay, because only the thing is we need to observe. But even this Laplace equation is very helpful to us, guys, because if Laplace equation or that particular thing is not there and it becomes zero actual. Okay, that's what this is also one of the important point we need to observe, because at the moment you are making use of that zero into something, it becomes complete zero. So as to avoid that particular convention, I can make use of this Laplace equation also. Okay, so that is what I want to give some kind of information about the naive Bayes and the corresponding probability structure, and how a typical naive Bayes classifier dependent on this probabilistic analysis so as to perform the categorization of the corresponding data, especially this naive Bayes or these are all having some sort of application friends. Let me pull some of the applications, and in between you can ask me any doubts if you're having. And in the applications, like especially for us, it is very important to understand the advantages, drawbacks along with the applications. Let me pull those points here. Have a look on this, guys. Okay, so which are all the applications? Okay, I have compiled some points for us. In case of the real-time prediction, just now we have seen spam or non-spam kind of thing. And then multi-class predictions, maybe greater than the suppose I'm having the two variables is a binary classification. Sometimes there may be a possibility of excess things also, maybe multi-classifier. That definitely I'll cover one more example on that case. Text classification, especially your naive base is best suitable for the text classification. Just now we have seen ham spam or customer feedback analysis. For all these text-based kind of the analytics, the best possible algorithm is your naive base. And similarly, what is the advantage is simple and highly scalable, and it works for both small and big data. Huge amounts of the data also you can apply. And the main important aspect is considering the weak learners. Okay, because this algorithm keeps track of there is no strong, there is no weak kind of thing. Give priority to all the things. A binary and also multi-classification. In both the cases, you can apply this naive Bayes, and great choice for the text classification. Just now we observed. Okay, rather than the I mean normal values and all is always naive Bayes. Preferably, you can make use for the text classification as a first priority. And the cons are there, friends. On the other side, practically, if you observe the real-time data set, the assumption is not holds good, friends. Like I cannot give equal priority to all the features. Okay, it cannot give any valuable information for us. And consideration of the independent feature is also it is quite impossible, or it's not quite natural, friends, in terms of the data sets and all. Not ideal for the numerical features. Numeric kind of the data, you can select any other algorithm. It consider all the features to be unrelated. It cannot learn the relationship between the features because it is not trying to establish a kind of the relationship between these things. Friends. Rather, it is studying about the individual features and all. It's not trying between establishment of the some kind of understanding, at least understanding of the relationship between the features. Sometimes it may becomes a barrier kind of thing. Now, estimated probabilities are less reliable than predicted values. Probability we are saying, not exactly the value. Friends. Maybe here, if you observe what we have seen, maybe 37.5 percentage or 49.5 percentage. And based on this particular thing, we are saying that our specification is belongs to the spam orientation. So these are all some of the pixels. Definitely, every algorithm is having that, but of course, based on our requirement, we can perform the activity related to that kind of the convention. Okay, so that's all, guys. And any doubts, please let me know.
Points super clear.
Okay, thank you. No problem. So next, what I will do is, Purna, just will see some example case study, and then we'll start with the support vector machine. Okay.
Sure.
So thank you, and do well, prepare well, and if you are having any doubt, post me in the teams, right? Okay.
Yes.
Thank you.
Thank you.
Hi Krishna, how are you?